Hi everyone. Today we're going to learn some more formulas that'll help you with these trig functions. We're going to learn the multiple angle formulas. We saw multiple angles back at the beginning of the chapter when we were solving trig equations. It's basically when you have like a 2x or a 3x or a 10x instead of just an x in your problem. Now we're going to start with the most simple one, which would be a double angle formula or a 2x. And what these formulas are, if you think about when we did our sum and difference formulas, it's for taking something and making it more simple. Like with the sum and difference formulas, if we had u plus v, we wanted to split those separate. Well, these formulas are going to take a 2x and turn it into single x's. So here are our three formulas. Here's our formula for sine of 2x. Now for cosine of 2x, you can think of it as three different formulas, but kind of like when we talked about Pythagorean, it's three versions of the same formula. We have cosine squared x minus sine squared x. That's basically our main formula. And then each of the other two comes from using Pythagorean identities to convert one into the other, either converting that sine squared x into 1 minus cosine squared x, or that cosine squared x into 1 minus sine squared x. Our third formula is for tangent of 2x. And as I mentioned before, these formulas are for taking that 2x and changing it into a formula that has only single x's in it. All right, so let's start with an example. We are going to be solving for x. That's been one of our main things this chapter. But what you guys notice here right off the bat in the question is we have a 2x there. Now the other thing is this does not have a 2x. The cosine function just has a single x. When you're solving equations, when you're solving trig equations, you always want the angle to be the same. If one of them has an x and one of them has a 2x, we can't really work with that. If they're both x, that's great. If they're both 2x, we can work with that, but they have to be the same. So what I'm going to do, I'm going to start here and use the formula I just showed you for sine of 2x. So let's do that substitution. We'll leave the 2 cosine x here. Now the formula I just gave you for sine of 2x was 2 sine x cosine x. So step one is done. We got the 2x out of there. We have only x's in our problem, which is good. Now step two is actually solving. I notice it's equal to 0, so I can think about factoring. Then I notice I have a common term, cosine x, that I can factor out. So let's do that. We actually could have also factored 2 out there. It doesn't really matter if you factor it out or if you leave it, it's going to have the same answers anyways. But because I factored, I'm going to separate and solve. So I have either cosine x equals 0 or 2 plus 2 sine x equals 0. Now the first one is ready to solve. The second one we need to isolate, so I'm going to subtract 2 from each side. And I get 2 sine x equals negative 2. And then I divide by 2. And this is why this dividing by 2 step is why it didn't matter if you factored out that 2 earlier. So what we have is either cosine x equals 0 or sine x equals negative 1. Now, if you think back to what we've been talking about for solving equations, I didn't give you specific directions on how to answer. So we're going to use radians, and we are going to give all solutions. We're going to use that plus 2k pi. Now, from the unit circle, there are two places where cosine is 0. That would be the top and the bottom. That would be pi over 2 and 3 pi over 2. Now, there's one place where sine is negative 1, and that's 3 pi over 2 again. So we don't need to say it twice. There's basically two answers from the unit circle. And what I'm going to do is I'm going to take each of those answers and put the plus 2k pi on them. I'm going to put pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi. Now, if you left your answer like that for me, that would be fine, but there's actually a way we can clean this up a little bit even more, and I'm going to show you that right now. Now, the reason is, if you think about it, the two answers we're getting on the unit circle are here on the top and here on the bottom. So if you think of it, instead of writing them separately, what we can actually write for our answer is pi over 2 plus 1k pi, or just k pi, because that's going to cover all of our answers too. That's going to start here at pi over 2. If you add 1 pi, it'll be down here at the bottom. If you add 1 pi again, you're back at the top. Add 1 pi again, you're back at the bottom. So sometimes, not every time, but sometimes instead of writing your answers out as two pieces like that, you can take your groups and combine them into one and simplify your answer a little bit. And I told you for me, I would not require that. Either of the two things that are boxed up on the notes right now are a perfectly good answer to me. All right, so let's talk about some other types of multiple angle formulas. Basically, we're not going to go any higher than 2x. I'm not going to make you guys learn formulas for sine of 3x and tangent of 4x and cosecant of 5x or anything like that. But I do want to say if you needed one, you could very easily derive it by combining the last two things we've learned. So I'm going to show you how to do that. So let's say for some reason we needed a formula for sine of 3x and we don't have one. But we can do that. All you have to do is this. We're going to combine the 2x formulas that we just learned with the u plus v formulas that we learned in the last lesson. So I'm just going to stop and realize that 3x can be written as 2x plus x. Now all of a sudden what we have is a u plus v situation. So I'm going to use my formula for sine of u plus v, where u is 2x and v is x. Now once you've made those substitutions, now we're going to use the formulas we just learned here and here. So what I did is for sine of 2x, I substituted the formula. Now for cosine of 2x, remember there were actually three formulas. It doesn't matter which one you use. I just picked the top one, cosine squared x minus sine squared x. Now we're going to finish it out by just multiplying. So on the first part, if you just have to, it's not distributive property, it's just multiplication. So you have 2 sine x times cosine x times another cosine x. That ends up squaring the cosine x. On the second part, I actually did a distributive property. I did this. And that's why I ended up with sine x times cosine squared x minus, and you actually end up with a cosine cubed x. Now for the last step here, I realized that these two are common terms, and I just added them together. So this is what I would say if I needed a formula for sine of 3x. I would use 3 sine x cosine squared x minus sine cubed x. Now remember, I'm not saying you need to know this formula. I'm not adding it to our list of formulas. I'm just saying if you ever needed one, this is how you could derive it. And if I needed a formula for cosine of 4x, I could just break it up into 2x plus 2x and do the same thing. Now just so you know, if you go any higher than 4x, it becomes a longer problem. Because if I wanted to do sine of 5x, I would have to write it as 2x plus 3x, and then I would have to do all the work that we just did to get a formula for sine of 3x, and then use that in the formula for sine of 5x. So it does get very complicated with the higher multiples, but you could do it. All right. The other type of multiple angle formula I want to talk to you guys about is a half angle formula, because a lot of times we don't think of this as a multiple, but multiplying by a half is still multiplying, so that counts as a multiple angle. Now what we usually think of it, we don't usually think of it as 1/2 times x, we usually think of it as x over 2. But the formulas are going to work the same way. If you see an x over 2 in a question and you think, I don't really want that x over 2 there, I would rather have just nice, simple x's, these formulas will do that for you. So here's the formula for sine, and here's the formula for cosine of x over 2. Notice they are exactly the same, except sine has a minus in there and cosine has a plus. And I'll talk about the plus or minus in front of them in just a second. Tangent actually has two different formulas. Those two formulas end up giving you the exact same answer. So it kind of depends on what works better. You can look at the question and decide. Sometimes it doesn't matter, just pick one and do it. Sometimes one of them is a little easier than the other. But let's talk about that plus or minus real quick. The plus or minus isn't like a plus or minus when you're solving, where it means you get two answers, a positive and a negative. What it actually means is you need to think about it based on, usually on quadrants, and decide whether the answer is going to be positive or negative. So I'm going to show you exactly what I mean by that in this example here. All right, so we are going to find sine of x over 2, and I gave you some information. I said sine of x is negative 12 over 13, and x is between 3 pi over 2 and 2 pi, which is another way of saying it's in the fourth quadrant. So let's note that first. X here is in quadrant 4. But x over 2 is not in quadrant 4. If you want to figure out where x over 2 is, what you can do is just divide everything by 2. Because see, then you're getting x over 2 in the middle. Now what that would give you, 3 pi over 4 is less than x over 2, which is less than, that's just going to be pi. So if you think about where x over 2 is, it's between 3 pi over 4 and pi. It's actually right here in this little shaded area of the unit circle, which is quadrant 2. So anytime I'm talking about x, I'm in quadrant 4. But anytime I'm talking about x over 2, I'm in quadrant 2. And as we work through the problem, you're going to need to remember that. That's one of the tricky parts about the x over 2 formulas, is we're going to use both of them. We're going to have to switch back and forth. All right, let's go back to the actual question itself. So I asked you to find sine of x over 2. Before we do anything else, let's start with our formula. Sine of x over 2 was plus or minus square root of 1 minus cosine x over 2. Now, let's start with the plus or minus. We're talking about x over 2, which we know is in quadrant 2. In quadrant 2, which is the top of the unit circle, sine is positive. So we've taken care of the plus or minus. It's going to be plus, and we don't have to worry about it for the rest of the question. Now what we do have to worry about, oops, not plus or minus anymore. I'm going to put the plus here just to show that I've actually thought about that and figured it out. What we do have to worry about is finding what cosine x is. Now, what I gave you in the question was sine x. If I give you sine and I ask for cosine, we've learned two ways to do that. You can do it by making a triangle, or you can do it by using Pythagorean identities. I'm going to go ahead and do the triangle. So I'm going to go down here to the bottom, and I'm going to draw a triangle for x. And I'm going to say what was given in the question, sine would be opposite 12 over hypotenuse 13. Now remember, you don't have to worry about negatives in a triangle. A triangle is always positive. We'll worry about the positive and negatives using quadrants. So if I want to find the missing side, I'm going to do a squared plus b squared equals c squared, which would be, we'll put the 12 here, maybe we'll solve for b. Now I'm going to kind of skip through the work on this. We'll put dot, dot, dot here. But the missing side ends up being 5. The 5, 12, 13 triangle is a very common Pythagorean triple. So now, the reason I did that triangle, remember in my formula up here, I'm trying to find cosine x. Now in that triangle for x, cosine is adjacent 5 over hypotenuse 13. So I have a 5 over 13 here, and there's one last step. Right now, remember in that triangle I'm talking about x, which is in quadrant 4, not quadrant 2. In quadrant 4, cosine is positive, so we want to leave that 5 over 13 positive. And like I said, that's really the trickiest part of these x over 2 questions. You got to be very, very, very careful realizing which quadrant you're in. If I'm talking about x, like I am in my triangle, I'm in quadrant 4. I'm going to use that for positives and negatives. If I'm talking about x over 2, which I did right here, then I'm in quadrant 2, and I'm going to use that for positives and negatives. All right, let's go ahead and finish out the question. I think what I would do here, the easiest way to simplify this is to multiply everything inside the square root by 13, just to cancel out that fraction. So what I end up with is if I distribute the 13 on top, I get 13 minus 5. And on bottom, I have 2 times 13 is 26. So I end up with 8 over 26, which reduces to 4 over 13. Now the square root of 4 is 2. I would say for my final answer, 2 over radical 13. And I kind of ran out of space there, but that's our final answer. So I switched colors around to make it easier to talk about. The work I did in green and first was all about quadrants, figuring out where x is and where x over 2 is. The work in blue is the actual problem itself, although the problem inside the problem was the work in red, where I had to figure out what cosine was, cosine of x. And just remember, as I mentioned earlier, you got to be very, very, very careful with positive negative signs and quadrants. That's the trickiest part for the x over 2 formulas.